Hello guys, so in this video we are going to be I'm going to be showing you guys how to install Anaconda. Anaconda is, in fact, it's like a platform on its own. It has several programs within it. In fact, I'll just summarize it. You can learn more about it on the internet, but Anaconda is a platform you can use for Python to program Python or to learn Python programming or to test Python codes. And Anaconda is very nice because you can keep executing different snippets, pieces of code, just like and scrolling down. You don't need to always rewrite and compile. It's like boxes of compilers joined together. So, like a compiler with several boxes, you can execute pieces of codes, you can test codes. In fact, it's very conducive to when you're learning programming. It's very conducive to use Anaconda for learning. Yes, because you can type codes in snippets. Code snippets are pieces of code, not complete full code, but snippets are just pieces of code. It's far more convenient than using the command line interpreter, or that's the Python interpreter, or the Python interactive prompt, sorry. So and it's very good for data science. Anaconda is very important for data science. Most data scientists use Anaconda. In fact, if you've ever searched data science online with Python, you always see them giving examples in Anaconda. Yes, so we're going to be looking at particularly Jupyter Notebook, because Anaconda comes in packaged with many other softwares. You can install like PyCharm, Visual Studio Code, R Studio for R programming, Orange, you have Orange and IPython and a couple of stuffs, but yeah, we're going to focus on Python, Jupyter Notebook, which is like used mainly for data science and to test pieces of code as code snippets. So let's get into the video. Um, so to install Anaconda first, I have a copy, so I'm not going to download it because it's quite large. You can see how big, 477 megabytes. So I am not going to download it, but I'm going to show you guys where you can get it from. Now, as a programmer, your best help is always Google. And I want you to know most programmers spend a lot of time on Google, even professionals. I've been coding for 10 years now. I started coding like when I was in 200 level in the university. That's around 2012, 2011, 2012. And throughout that time, I've done a lot of coding in different programming language, maybe up to seven: Java, Python, PHP, JavaScript, Android, a couple C++, C Sharp, Visual Studio, Visual C++, and all those stuff. I've programmed in a lot of languages, but what I realized is while we code, we forget a lot. Programmers always forget, especially if you code in multiple languages. You're always going to forget a lot of things. Never think as a programmer you need to always cram and all those stuff. No. Learn programming, you need to know you're going to forget. The main thing about programming, what you actually focus on, is you should know this can be done and it can be done using this. So next time you want to do it, you just know, okay, how to do this. The main thing you need to know from a programming language is what can be done with the programming language. That's your main thing. Don't try to always cram function names, and if you're not able to cram it, you feel like somehow feel low and feel like, oh, I'm not able to go. No, you learn as you use. You always cram, you memorize all those function names as much as you use them. But if you stay 1 month without coding, sometimes you feel like you're just a beginner because you've forgotten everything, especially if you code in multiple languages, scripting language like Java, PHP, Python. Anytime you code in these three languages, like if I'm developing a website, you have to you tend to have a mix up because some stuffs are similar in these programming languages. So as a programmer, Google, we spend 60% of our time searching things on Google because we know what we are looking for, but we have actually forgotten it perfectly. So we want to be sure. So we just type how to find the length of a list on on. You just go, for example, if I've forgotten how to sort a function, I'll just like go to sorting list Python. You can just go to this or any of them, but you see you just see a sort function now here. Oh, okay, it's list dot sort. Okay, you close it. So you always forget and never be ashamed to search for something on the internet. Like as I'll be going through these tutorials, there are many times I may forget a couple of things. It's not a big deal. I'm not a genius to cram every programming languages. In fact, there's a lot in programming. Like Android itself is so large, Java so large, you can't remember. In fact, you can't remember a lot of things except you're actively coding in the language. But if you're not actively coding the language, you're bound to forget a lot of things. So I don't want you to think as programmers you must cram. Yes, I forget a lot of things always. Even with the experience I have in programming, I always forget. So I only refer to Google. Yes, thank God we have Google these days. Our parents did not have Google, but at least we have Google. So, and even in the early days, not even our parents, when I started coding, there was not really, the internet was not really as it is now. We mostly read books. I read most of my programming knowledge came from books, not the internet. So but now, because also there was 2G connection, you couldn't download big videos or all those kind of stuff, so we were bound to read books. So and when you forget something, you have to go through the books. You can't just go to some Google and begin to type stuff. So I think after some time things became much better. So this time now Google is your best. Never waste time if you can search it on Google. Don't try to say no, you must remember it and those stuff. So let's find how to install Anaconda on, just say Anaconda Windows, depending on your operating system, Windows download. So Anaconda Windows download, and we click here. You see there's a newer version, 544 megabytes. You see, so okay, I think no, it's the old version. So this is it. It's simple. You just click download. That's all. You understand, and you get the file. I am not going to download it because I have the file like I showed you earlier. I already have the file. Let me close this stuff. Let me close this stuff. I already have the file. This is it, 477, I think. Yeah. So I already have the file. So yeah, once you click save file, you'll be downloading the file. Take note of where maybe you'll be in your downloads folder or whatever. Way. I'm going to cancel this because I have the file. I don't want to waste our time here. So cancel. Now, I think for now I may not need the internet, but I will leave it. So let's go to the next step, how to install Anaconda. And you can also search that on Google. Google has everything, but sometimes. So, but I'm going to show you guys how to do that right now. So, you just follow the setup simply. Anaconda actually takes some time to install, so we just have to be patient most of the time. But I want to show you quickly. So, next, I agree. Just me is like just for this user or for all the users on the computer. Mm, I don't. Let me install Anaconda for this computer so that it will not affect the other side. So just me. Okay. And see that destination of Anaconda 3. You see, it needs to. Okay, I think it's good. All right. Mr. Microsoft. See that Mr. Microsoft. Yeah. Next. Okay. Add Anaconda 3 to my path environmental variables. Not recommended. Instead, open Anaconda with the Windows Start menu and select Anaconda into add. This add this add to path open makes Anaconda get found before previously installed software but may cause program requiring uninstall. Yeah, so you see they say not required. It's not very good. If you add Anaconda to your paths, what's going to happen is that settings commands are going to check Anaconda, which is not really good. So it's good to leave Anaconda to operate on its own, like open the Anaconda and run what you want. So don't check this. I don't want Anaconda to be my default Python executor because I already have Python installed. You understand? You see, this allows other programs such as Python tools or Visual Studio Python, to automatically detect Anaconda as prime. No, we don't want this. I have Python. Let Anaconda manage its Python on its own. I don't want it to be like the system-wide Python stuff because I may want to use Python without Anaconda. So I will not select any of those. So from here I go to install and that's it. You can view details if you want to see what's happening. You know. So that's we installing Anaconda now. So let's give it some time. Alright, it's trying to do some stuff. I don't know if it's trying to download some stuff from the internet. I think maybe, so actually takes some time, so we're just going to wait. Okay, so we have to, it's completed now. I actually have to cut off some of the time from the video. So next, all right, next, Anaconda stuff, one or two stuff, getting started. We don't want to open any of these tutorials, no, so finish. So what next? So first thing first, we have to try to put Anaconda. I'm going to close this, we don't need this again. All right, so we have to try to put Anaconda on, we need to create a shortcut, and this is what we are interested in, an Anaconda navigator, not the prompt. Sometimes we may need to use the prompt, but not in this video. Okay, so what we are interested is in this, you understand? So what we want to open the file location so that we can create a shortcut. Luckily, this is not the actual location. If you want to, since you have this arrow, it's still a shortcut. If you want to know where it is actually found, you need to still open file location. This is the actual part, as you can see. So you see, Anaconda comes with its own installation of Python. That's what I want you to notice. Look, this is the Python. If you watch the previous video, this is the python.exe file. This is own Python interpreter. Like, it comes with Python, it installs Python. You understand? It installs a version of Python. So that's why it can be used as the default Python, because it also installs Python, but we are not interested in that. So we don't want it to be our Python default. In fact, if you install Anaconda, you don't need to install Python if you want Anaconda to handle everything, because Anaconda actually installs Python with it. You understand? So that's just what I'm trying to say. If you install Anaconda, it comes with Python. You understand? So if you don't have a separate version of Python, you can even use the Python from Anaconda. Yes, but I did not check that, but you can still use it. You can still configure your computer such a way, use the Python that came with Anaconda. So that's just it. So I need this shortcut. We cannot drag and drop because it's going to remove it from here. You see, it's not good, and the computer depends on this. So we're going to just Control C, Control V, copy to here is it. So we can close this. We don't need this again. If you don't do this every time you want to run Anaconda, you can. One other way is you can also pin it down here. For example, you can pin to taskbar. Let me show you. It's not here, but if you want to pin a program to taskbar, you just need to right click and pin to taskbar. Okay, this one is pin. Yes, all these are pin. So well, I'm going to show you with Anaconda. So let's run Anaconda. All right. So it takes some time. It takes some time. Initialize. It's going to do some work. We're just going to give it time to function. All right. So here is Anaconda. Now, like I was saying, if you want it to be pinned down here, just click pin to taskbar. What? Where did it go to? Alright, it went to taskbar. Wow. Where did it pin to? Like, I don't understand. Like a small error or something. I'm going to close it to understand what actually happened. On pin, I don't know. It actually is using a different icon. Well, I did not actually want to pin it, so malfunctioning. So well, let's close it and like this. I don't want to actually I will unpin from tag by it's not using this correct icon. I don't know why. Programs misbehave all the time. So we have to just accept it. So all right, so here is Anaconda. I want to show you some things. Here we have Jupyter Lab, we have R Studio. Visual Studio is not here. I don't know why. Visual Studio Code used to actually be here. I don't know why it isn't here. It needed to be here, but like we don't need it. So you see, you can install PyCharm. Most people know about PyCharm. It's done. You use it for Python, HTML, and many other stuff. It's a common IDE tool, but we are not going to use that. What we are interested in is Jupyter Notebook. And to install Jupyter Notebook, we need to be connected to the internet and we click install here. Make sure you're connected to the internet. You see, I'm connected to the internet here. What? Environmental not found. Not a conda environment. See, program data Anaconda. Okay, so I'm going to check out that error right now. All right, there was actually an error, but it looks like everything went on very well. Let's try to launch it. These programs misbehave at times a lot. All right, so we are good to go. Now, Jupyter Notebook uses the browser to open. It runs on a browser, so don't be surprised. Each time you launch Jupyter, it runs on a browser. You understand? And when you want to open Jupyter Notebook, you need to open Anaconda first and then launch it from inside. You can still launch Jupyter directly from here, but I don't encourage that. It's always good to launch it from Anaconda so that Anaconda should have some control over it. So you can minimize this. So where is Jupyter? Jupyter always runs on your default browser. So here is Jupyter Notebook. Now, there are a few things you need to see. If you want to create a new project, just create a new Python 3 project like this. You can do it. You understand? It's going to save in a default location. Look where it is. Notebook stuff. And you can now save it, save as something like that, and specify paths. But I will not always encourage this. It's usually confusing to work on that. So what I encourage you to do is create a folder somewhere. For example, I have a folder on my desktop right now called Python projects, leak clips from the previous video, and I will create a new folder called Jupyter. This is where all Jupyter stuffs are going to be. Jupyter. I can even say Jupyter projects. You understand? So everything should be clear. Now, what you do within the Jupyter place, you now have to go to desktop. Okay, select Python projects or Python. Okay, yeah, Jupyter. Here now, this is where you now create a new Python 3 project. And as you can see, actually saved in that location, Python project, Jupyter, and all this stuff. Now, watch something. If you go to, now we need to just save this. Let's just save this with the name test1. Save as. Notice, see, we say test1. Save. Unexpected error while what this one no storage directory as C program. Don't know, so they really have this problem. Like, let's try to arrange it. Desktop Python projects. I don't know why they always have this problem. Python projects, Jupyter project went. So the percentages the Jupyter added automatically was actually the problem. So these applications always misbehave and you just have certain problems. And so now you will check. You must be ready for misbehavior at any time. So this is our program. This is test one now. It always comes with an IPy because Jupyter actually uses IPython to execute. I told you it's from the last video, you saw Iron Python or something. It uses IPython to execute. So you usually see it ends with every time you see test one.ipy notebook. So let's now close this. I want you to see something. So let's say you just came in and we wanted to open that project. You like from the base, from the default screen. We can open any Python notebook file by going to the location. This one is in our desktop, Python projects, and test one, Jupyter projects. Look, you see this one is already running because we launched it, but take note, you see it shows like a book. Once it shows like a book, it's a supported file. It's supported by this Jupyter notebook. So you can open your project at any time. Just go to the location and open it. For example, let me not let's do it. Let me not be telling you guys something. So you guys, let's say we have created an empty Python notebook file, and something happened. We have to close our notebook and everything. So now, how do we go back to this file? Here is the file. I just want to show you guys so that everything is very clear. Here is the file we created at that time. To open it, because many times you actually want to go back to a previous file. To open it, you need to launch our Anaconda normally. All right, just give it some time. All right, so in this case we have it look like the newer version of Jupyter of Anaconda doesn't come with Visual Studio, maybe some license stuff. But before you see Visual Studio around it. But I think if you have Visual Studio already installed on your computer, it's going to show here. You understand? So, but I think maybe there's some license issue or something. But whatever. So in this case now, we already have a file. So let's launch our notebook from here. It will always run on a browser. So I don't know. I'm going to solve this sometime. Environment location not found. Not a corner environment. C program the program that Anaconda 3. We are going to look at this problem later. Let's see. All right. So it's going to use our default browser to load up. Did he actually load up or something? Like, don't know. These programs always misbehave all the time. So you just need to be patient. All right. So desktop, um, Python project, Jupyter. So you see, the other stuff are not showing like books. You see, but when you open a project, a Jupyter file, you see it shows like a book. You understand? So this was the default. We don't even want this. We can delete this stuff, delete. Now we just double click this and it's going to open in a new tab. Now, so let's get started with now the way Jupyter Notebook works in the form of boxes, like cells. Like each cell is like a small interpreter of its own, but the cells are linked together. Let me show you an example. Print. Sorry. So print. Hello Python. Now to run a cell, you can use run. You see, it runs. Now let us do something that takes a bit of time. Import OS D, for example. Run. There's an error. Now notice each time you run, there's a star showing before the number actually shows. And these numbers are just, they don't really mean a big deal, even though they mean, for example, I can say print, um, print, print in um, 2. You see, it prints. So you can use these numbers to print. You can actually print these numbers at cells, but the numbers themselves don't really mean a lot. That's what I just want you to know. They don't really mean a lot, They're just like giving you the lines so that you can be able to describe it to somebody that, okay, go to line, this line, stuff, all those stuff. So it's easy to delete a cell. You just need to click delete here. Where is delete? Cut. Yeah, disappears. You can cut this. You can cut this one too. If you want to create a new cell on your own, just click on this cell and press plus. A new cell will be created under this one. So there was an error here. Take note, as I press run, you're going to see a star here before the actual number. Look, all right, it did not take a lot of time because it was too short. But each time you see a star showing here, it means it's still being interpreted. Interpretation is not over. The Python interpreter is still interpreting it. Once the numbers show, it means it's successful. So now I just want to show you these cells are linked together, even though they act separately. For example, I can say int, sorry, over 1 equals to 10, over 2 equals to 20, 30, product equals to over 1 times over 2. Then I just write product and I use run. Now it also behaves like the interpreter, like we saw in the first video. If product, I just called it, the product actually returns something. But since I did not return it anyway, I did not assign it to a variable. What happened, like this product, it just printed out. I will have still said print product. You understand? You can still do like this. All right, one other stuff I want you to know is the shortcut for executing a cell is control is shift enter or control enter. So from this point, I will be using the shortcut to execute cells. So don't be surprised. I'm not going to always be clicking run, run, run. It's time consumes a lot of time. So I'm using shift enter. So now this cell is still linked to the cell above. Let me show you. For example, print. Wow. For example, print 1. Shift enter. It printed 10. So the cell is actually like the same program. You understand that there's like it's just like putting your codes in compartment. And not only that, you can also use Jupyter like for why people use it to teach, because you can also change a cell to some form of an HTML document. You understand? So it's usually very important. So I'm going to show you here. All right, so I'm going to show you how you can change this cell to a code. So for example, look, now it's code. You can change it to markdown. Markdown means it should be HTML format. So in fact, if I write something like B bold and bold, why is it so bold? If you know HTML, you know, for example, using strings, and bold, and okay, using strings, I can say italics, double quoted strings, or for those who know HTML, I can say style equals to color, color equals to green. And maybe the next one, if forgetting this, this font size. Yeah, I think this color green font size. Font size. I think it is. So you can do something like this. You know, like using. Alright, I did not even end it. Alright, so did I even end it? I started with I, double quoted string, and color equals to green. I think I'm making some mistake here. Okay. I needed to use single quotes because I had already used double quotes. Like unitary style equals color. Or maybe you can't use style, I don't know. But so I'm just going to leave it as italics. So we don't waste a lot of time. But maybe you can use styles. I've never really done much of that before. So you can do like this. I'm just trying to show you this when you use Markdown. It's for HTML. Do you understand? It's for HTML stuff. I don't know. Let me see. Color equals to green. I don't know why this does. Right, it look like styles don't really work here too much, but I believe style works. Style works. I just believe if you go on the internet, you'll be able to learn how to do that. So yes, you can use it for documenting and many other stuff. That's why people like it. You understand? Since you can use it for documentation too. Let's be fast. Let's forget about this. So let me delete this. So I'm just trying to show these cells are linked together. These cells are all linked together. You can you can write pieces of code. For example, let me just show you this one equals to um, 2, 4, 6, 8, 12, 13, 15. I say for x in list 1, print x squared, print x squared. Let me see, am I totally correct? Yes. So we see you can do everything. You can even do list comprehension, which will, for example, you can create another list. And this point, if you can still create a list and say list one, you will not replace, will not affect the upper cell because it goes downward. You understand? So but let's just say list one now. Let's just create a new list one equals to 1, 3, 4, 6, and 3, no, 6, 7, 9, 12, 22, 23, 21. We can even create another list from this list using list comprehension and call odd, even equals to. We are going to learn all these things. I'm just showing you how this can be used for fluid stuffs. So you can say equals to um, um, x for x in list 1 if x mod 2 equals to 0, print even. So that's what I did was I used this comprehension to create only to pick out the even numbers from this list. You understand? So we are going to learn all this, but I'm just trying to show you you can actually do a lot of coding with Jupyter. And look how nice it is. You understand? We're just going down. We don't need to create files and begin to compile them, and we just keep testing our code going down. We can say we want to print all odd numbers, all even numbers between 1 and 100, between 1 and 100. What we start, we just create numbers equals to range 100 or 101. You understand? We can say now we can create a list equals to we can create a list, maybe list 2 equals to only even numbers. So but let me use a while loop. Start equals to numbers. I want to also notice that one small disadvantage of using this is that there's no code completion. You see, you have to type everything on your own, no code completion, nothing. You just need to remember. So it's sometimes a bit difficult to use this for big project, because big project you expect the IDE to suggest stuff to you, not you just typing everything on your own. Even though there's some color in there, So let's say numbers, you see numbers. So see what I'm going to do now. I say I want to numbers 0. Yes, so we should start from the first number and last number. Last is equals to numbers -1. Numbers -1. We are going to learn all this. I'm just showing you guys. So we can use a while loop. While start is less than last, print while start. So what we are going to we want to pick out only odd numbers from this list. You understand? We are going to pick out only odd numbers from this list, but we are going to go through the whole list. Okay, if while start is less than last, if sorry, if last is equals, if last mod 2 is not equals to 0, it means it's not an odd number, it's not an even number. Print, in fact, I'm not even going to print it. Let me store it in a list called results equals to list this. So what we're going to say, we're instead going to append results. We're going to say results dot append, and need to know the current. Yes, last, no, not start. Yes, let's mark the current index. Okay, start index is 0. Okay, start index is 0. All right, start index is 0. So we are going to have the current item should be equals to numbers. This can be complicated sometimes if you're not used to start. Okay, so we say while start is less than last, current item will be numbers start as index, and start is 0, so current item will be 0. So if current item mod 2 is not equals to 0, it means it's not odd. Result.append current item. So in this case now, we're going to learn all this. So from here, what do we do now? Result.append current item. So at the end of the day, then what we're going to do is that we're going to now increase start by 1. Start plus equals to 1. So the loop will continue. Now, if there's any error, we're going to connect. Let's print now results. Results should have a list, should be a list of all. Alright, so you see result is a list of all I stored it in a list so that I should print in this form, in a spreading form, not or vertically to take a lot of space. But if you look now, result is an extraction of all the odd numbers from numbers 0 to 100. So that's just so now you can use you can use Jupyter Notebook for this kind of stuff. Like I will be using Jupyter Notebook when I'm teaching you guys most of the time because as you can see, you just code going down. You don't need to worry about executing wiping and creating new code. You can even go back to old code to check stuff. And I want you guys to know these cells are linked to each other. For example, print numbers. It's going to print the latest variable assigned to numbers, which is this, so that you see what numbers. Sorry, it's control and shift enter or control enter to execute a cell, or you can just run it from here. As you can see, it's range, but you can, if you want to actually see it, you can convert it to a list. Print list numbers. It's a range object. So this is what is actually in in fact, range object is something like a generator. We're going to learn all those things later, but if you want, you can convert it to a list by extract. So you see, well, range actually were the values from 0 to 100, but our code actually extracted only odd numbers. That's why we had 1 to 99. So that's just programming. So we're going to learn how to do all this kind of programming in future videos. So now the main use of Jupyter is for data science. Most of the time you may have heard about that. So what do we do? How do we do? Let me show you an example of some of the kind of stuff you can do with Jupyter in relation to data science, like plotting of graphs using the most popular matplotlib library. So for example, let's see matplotlib is installed. Oh, Jupyter comes with matplotlib. Let's see if numpy is installed. Import numpy. Oh, Jupyter comes with numpy. So that's the advantage, which shows you that Jupyter already knows it's being used. The designers know Jupyter is used mostly for data science. So it comes with, that's Anaconda. Jupyter particular Anaconda comes with um, matplotlib installed, numpy, scipy, I think scipy, sorry, oh, scipy. So all of them are import, but let's say we want to import something that does not exist. How do we do it in Anaconda? I just want to show you, like, I'm looking for a module to import. Okay, let's say like a module called xarray is too big. Um, Let me look for Python popular modules online. I just want to show you guys how to install a module in case you need a particular module and it's not available. Here, Python popular third party modules. Okay, let's say Scrapy. Okay, pillow. Let's see pillow script requests. Let's check requests, import requests. That's for web stuffs. Let's check if request is there. I think request is there. Yes. Sorry, I don't need this. Um, let's say import request. Let me use this import request. It's installed. Scrapy. What does Scrapy? Let me check what is it. Install Scrapy. Scrapy. Okay, so Scrapy is not actually installed. So I want to show you guys how to install Scrapy. So for Anaconda, you just need to go to here. In fact, you do this. You go to Anaconda prompt. I type conda install Scrapy, something like this. I don't know, it's supposed to should be colored. I don't know why there's no color. So this is how you install packages on replace every any package. In fact, if matplotlib was not installed, we'll just write conda install matplotlib. You can also go online to learn how to install these stuffs, on your own, like Django, and you can install all this through Anaconda by doing this. So let's wait for Anaconda to like get it. Usually takes some time. I don't know. Mm. All right, so Conda is wasting a lot of time. We are going to cancel this, and we're going to go to environments and go to this. We can use the normal pip install, open terminal. We use pip install Scrapy. I've already tried this before coming to the video. Scrapy. So I think this may be faster than Anaconda trying to do it itself. All right, it's okay. Yeah, it's faster. Anaconda is so slow to. So you can use any of the two methods. If conda install cannot work on the Anaconda command prompt, just go to Anaconda from the Anaconda navigator, go to environment base, and you use this arrow and go to open this terminal. So in this case, this is how you install. I'm just showing you guys how to install a package using Anaconda in case you need to use a particular package and it's not available. You understand? That's how you do it. So look like Scrapy is really a big stuff. It takes a lot of time to install, doing a lot of things. Did not know. Wow, it does a lot of things. Like, all right, so it's done. Once it's done, you can close this terminal. Let's go back to our Anaconda and try to see if Scrapy is shift enter. All right, so the import was successful. So I'm just showing you guys how to. I'm just trying to show you guys how you can install a package if you need it and it's not available. So now let's see some things you can do with Anaconda related to data science. So let's say, for example, we want to plot some graphs. For example, let me plot a simple graph. I'm going to show you guys three examples. So we already have matplotlib installed. Import okay, from matplotlib import um, um, pyplot as plt. Then we also need numpy for this example. No, let me not use numpy for this example yet. So let's just say we have create a list of the x-axis, because for every plot, you know, we need an x-axis and a y-axis. So you can go to this 30, 42, for example, let's say 55 for 68 and 77 and 88. Next, let's say y equals to 1 for 9, 16 and 25, or maybe 37 or 36, and then let's say 49 and 64. Okay, we're good to go. All right, so now we have values for the x-axis, values for the y. We may learn this in future, like this data science. So like, but just I want to just show you examples. Maybe you can be interested in this if you're interested in data science. Figure, create a figure. It's called plot. Plot, you know, is we this is the plot. We actually imported the pie plot as plot, so we are calling it. We call the plot object, we call the figure method of the plot object. And next we are going to create an axis. All this, I don't want to go into details of all this axis and this stuff. We are going to call the add axis stuff method axis, and normally it takes in a list as parameters. That list normally has four variables. We usually say 0 0 comma 1 1. It has some meanings why that is being done. So now we want to plot the line. It's actually a line, so we say line equals to axis dot plot. Now we have to give it the x value which is stored in x and the y list which is stored in y. And now some configuration parameters just tells it how to operate, and also it should be dotted lines. All this you should not worry about. Axis dot, we want to set the title of the axis because a plot without a title looks funny. um let this be, let me say, gross effect, and let this um, be set y label let us set the y-axis name. Let's just call it sales. So the next one now be plt, like plot.show. We are calling the show method. Let's see if there's any error. You see it's still interpreting. The interpreter is still interpreting it. After that, now you have a graph. So let's see what's our result. So you see, nice plot, very simple, growth effect, sales. So that's why, and you see it's very simple because you just keep going down. Everything is being saved, stored. So let's look at the next example. You see, this is a simple this thing. Let's try to plot maybe a sine wave function or something, a sine wave or something. So here is a simple example. We have already imported a matplotlib. I told you these cells are connected to each other, so you don't need to come and say from matplotlib again. We are going to use the old one. Okay. So, but I think, do we import numpy here? No. So let's import, because in this example we have to use numpy to help us generate some values which are a bit complicated to generate as np. You usually see them, because if you just say import numpy, it means everywhere you want to call an object, I mean everywhere you need to call a method of numpy, you need to say numpy dot something. So we usually use as np, so that it's like a short form, it's usually called an alias. An alias is a short name of some another a longer stuff. So np is an alias for numpy. So every time we say np, normally we are actually saying numpy. We're going to learn all that. So um, let's say we create the we need to also import maybe maths, because I'm going to use math.py. I'm going to use the py stuff for math from the maths module, the py method. So let's create the x-axis values. So this is where we need numpy. Numpy has a method called arange that creates a range. It's similar to Python range, but it's more verbose. You can create complex ranges. Like for example, look at the kind of range we are trying to create, times 2. And not only that, one advantage in numpy is that x is going to have a range of numbers. You can just say x times 2. It's going to multiply everything. Instead of saying for x in this in x times 2, you just say x times 2. It's going to multiply everything in the x within the x array times 2. You're going to see what you see an example of what I'm saying. So it should be in ranges of 0.005, 0.5 or something. Let's see. So now look at what you're going to do. 0.05. Yes, I don't know what it is. Let's say this. So x math.py. This math.py is, we are calling the py is not actually a method. It's a py, it's like an instant variable. It has a specific name. the pi property, you can call it a property of the math model. So we call the pi property because the value is not actually a method, it's not like a function. So we call the pi either the pi instant variable or the pi property of the math model. So it's actually 22 point something something, but you know the value, you don't want to cram it. So create the y-axis. Y-axis is just as simple as numpy dot, we now want to call the sign of everything in x, so say numpy dot sci x. So in this case now, we now want to plot by calling our plot. Remember the plot from the previous plot dot plt dot plot, pass it the x and y. Next you have plt dot x label equals to angle, and plt dot sorry, this is supposed to be x dot y label, we call it with sign. So next we have plt dot tie to equals to let's just say the sine wave. So now let's look what's happening here. Let's try to run this, see if there's any error. Okay, no, there's no error. So here is your sine wave. Okay, so it's let's do the last slide. Let me show you how to plot histogram. This one is going to be the third one. So we already have matplotlib installed, so we are just going to say figure equals to plt dot figure, and the axis is equals to figure dot add axis. Usually know this takes a list, and we usually say 0 comma 0 comma 1 comma 1, sorry, 1 1. Usually it takes a list of 4 items, 0 0. Now langs equals to we want to say the languages, we have C, we have C++, we have Java, we have Python, and we have PHP. Those are the different languages. Now we want to create another axis called students. You know how not a pie chart, histogram, um, or a bar chart, not really a histogram. Like we want to draw something like a bar chart. So 23 students for C, 17 students for C++, 34 students for Java, 28, 26 students for Python. Usually Python is supposed to be the highest level. And let me say 10 students for PHP. So in that case now we're just going to say axis dot bar, and then it's going to be, let's say we're going to pass it length as the x-axis and students as the y-axis. Now we're going to say plot dot show, and let's see if there's any mistake. Right, so yeah, I'm going to end here for this stuff. So I'm just going to, I've shown you how to use it. So we can save this. To save, we just use this save stuff. You know, we already saved it using file save as. You know where we saved it. You know this place. So we saved it there. So once you've saved it one time, you can just save like this, and that's all. So you can do a lot of things. You can export this as a Python file. You know, you can do, where is even export? Okay, download as, yes, you can download it as a Python file. But most people try to export this as HTML. It's very important. Let me show you. Let's save this in our desktop. Let me show you. Okay, see, Let's get this. Control X. Now look at this file. This is the result of our. This is the result. Let me close this so that you don't think it's just from Jupyter. You can even open this with Brave or with Microsoft Edge. See, now we exported it as an HTML document it on its own. That's why people like using Jupyter. Look, even the graphs, everything. So you can give this to anybody. That's why it's used for data science. The codes are there, everything is there, and all your code is there. Yes, from here you cannot execute it, of course. It has been converted to HTML. You understand? So very nice to use. So that's why they call it a notebook, because this our Python code base is now like a notebook. So I've shown you guys how to do this, how to use Anaconda, at least for it to start up with Anaconda. You can now use Anaconda to do your stuff together. So I can close this. So that's the end of this. In the next video, we are going to start with the first module of the book, of the manual. We are going to start following through on the manual. I just wanted all the environments to be set up, so when I start coding, everybody is going to be in line. So thank you very much. In the next video, we are going to continue. So have a nice time. See you later. Thank you.